Hello, everybody. Welcome to the Rhino user group meeting. I have a few people to introduce you to here. I'm Paul from Simply Rhino, by the way. I think most of you may know me. So this evening, there's two presentations. One from Arthur and a second one mainly from Phil. So the first presentation is a customer presenting their use of Rhino and Grasshopper in a very interesting and award-winning way. So Arthur will introduce himself in a moment, and then the second part of the evening is a presentation on the most sort of interesting features in Rhino 7 that's been put together by Phil. So it would be great if everyone could introduce themselves, just the other five here that are on the screen. If we could go round, starting with Phil.
Hi, thanks. I'm Phil Cook. I'm a trainer at Simply Rhino. I'm also a product designer, and the presentation we're going to be looking at of mine later on is, as Paul said, some of the new features in Rhino 7, but not all of them, just some of the ones that I wanted to look at, which are, you'll see shortly, but sub-D, QuadRemesh, some of the new rendering features, and a few other things as well.
Okay, Carlos.
Good evening from Barcelona. I'm Carlos Perez. I'm working for McNeil Europe, and I'm responsible of sales and marketing in the region.
Thank you. Vanessa.
Hello, everybody. I'm Vanessa Stegg. I'm working for McNeil as well. I am a tech and a trainer and do a lot of training material as well. And I'm here just to support the webinar and support Phil. If there are any questions.
Excellent. Scott.
I'm Scott Davidson, and some of you have met me before. I'm missing being in London this week, but hopefully this all goes well. So it's good to see everybody here.
Thanks, Scott. Now, Arthur, I guess you're going to be presenting up next, but you could just say hello briefly, and then we'll hand over to you. Just a couple of things. The whole meeting is being recorded, so it will appear on our YouTube channel a few days after. I think that's all there is to say for now, and then I think we're going to hand over to Arthur, and you can begin your presentation, Arthur.
Fantastic. Thank you, Paul, and hello, everyone. Thank you so much for being here. My name is Arthur Mamou-Mani, and I am indeed a happy customer, and part of the community of Rhino and Grasshopper. And you probably have attended, maybe some of you, my classes with Simply Rhino since 10 years anniversary of teaching Grasshopper level 1 and level 2. I am going to share my screen, monitor 2, and I'm going to start a little presentation. The general idea of the presentation is to, well, I guess show you the spirit of the community. Can you all see my screen?
Yes.
I guess that's a yes. Yeah,
we
cool.
Can see it. We can see
Fantastic. It. Great. So I'm going to show you a few slides of our latest work and what this work means to us, and why I think it's important to share this with you, because in essence, I think that, and I hope you agree with me, that Rhino and McNeil is more than the software. It's actually a community of people that help each other, people that write plugins in their spare time. And so I just wanted to show you not just our work, but also the work of our collaborators, people like Aaron Porterfield or James Solly, who are engineers, designers, people that I guess help break the boundaries of architecture and into other fields. So design is first and foremost joy and people, and the Rhino community is actually all about that. So I'm speaking to you from our office in Hackney Road. We're actually sharing office with Simply Rhino. We are pretty much not just architects, but also makers. We have a big fab labs called the Fab Pub, and we're actually using it to make big scale prototypes, slowly turning ourselves into contractors And you know, I mentioned it before. It's a luck. We're actually 10 years into the making of these classes. You know, COVID has changed quite a bit of things, I'm sure for you too, all around the world. And so we've ended up reaching out to a lot more people, strangely enough. COVID has also, or should I say the confinement has changed the way we've worked, not just in, you know, in the kind of teaching world, but also in the way we practice. For example, Catharsis here that you're seeing ended up being in a virtual Burning Man experience, which was really new for us and quite refreshing to see and interact with people with Avatar. So this is our ecosystem, and I'm going to show you more widely you know, how we work with engineers. How did Grasshopper has, let's say, broken the barriers between the architects, the engineers, the makers, the software designers. It's really that I think is at the core of this community is the way we've all ended up collaborating and opening up our field of vision to more stuff. So this is the team. I'm super happy. We are, I think, about 12 now in the office, people from all over the world, and sharing a common vision. So I'll try and summarize it roughly, but I think we are trying to get a sense of a holistic approach to design. That does sound a bit spiritual, maybe it is, but really by connecting all our files together, all our algorithms, we end up, you know, sending you know, scripts to engineers, and they end up sending us back things. And the boundary between design and engineering, the boundary between design and making is blurring. So we are the makers of our project. We ended up being contractors on quite a few projects, including the Galaxia project that you're seeing here. And so we create architecture that grows from parameters, whether to call it parametricism or if someone has a better word for it, I don't know, but I guess that's what we are. And so we do digital fabrication, understanding and working with the machine, empowering other people with the community of Fab Labs that are out there, and sharing design and ideas around the world. Which strangely enough realize them locally, which is one of the most beautiful thing I find, is that when you end up decentralizing the means of production, people end up being extremely local with the fabrication, much less shipping. So I guess you probably have seen maybe some of the work that I was doing, or some of our students were doing at Burning Man, the event. This has really broken the idea of that buildings should be permanent. I'm sure you've seen many people doing pavilions using Grasshopper. This has helped us not just understand the making of things, but the fact that things can be temporary and disassemblable, in line with the idea of circular economy. We've pitched for a giant new kind of robot for, you know, this is with Arup. Arup ended up helping us with a grant to develop a cable robot, and the idea was to assemble and disassemble skyscraper. So this is a mixture of a 3D printer, a Delta Tower, and a spider cam for stadiums and so on. So we've ended up doing this. It was a really wonderful project, but really the only reason we could do it is thanks to the community. Firefly, Silkworm, you know, you name it. We've used so many plugins in the making of this, and in the making of all our projects. And I think that's kind of redefining a little bit the economy, the way that we value things. We do these things beyond profit, beyond the idea that, you know, a tool equals a certain amount of money. I think we are all sharing knowledge. And in a sense, you know, there is also always this thing about the client will decide anyway, so what's the point, you know? You know, these are some of the examples I'll show you, whether it's Galaxia or the projects we've done at Burning Man. We always try and find a community that believes in what we believe. So we fundraise, you know, we fundraised about $500,000 for Galaxia, and all our students have fundraised for their project. So we don't have to wait for clients. This redefinition from, let's say, financial values to let's say just value, remove the word financial. I probably got it from my parents. My dad wrote a book, Beyond the Bottom Line, How to Reconcile Woodstock and Wall Street. Here they are. And I think in that sense, it's an introduction to who I want to introduce you. I know Aaron because he was online and he'll tell you the story. So I'm going to share the first surprise talk, and I hope this is going to work. I think I need to actually go to my sharing property, and I hope this is going to work out. This is relatively new for me, so let me go to, and I think I might need, I don't know, Stephanie, if you're still online here, looking for the button. I think screen, oh, I found it. Okay, great. Can you see a video? Yeah, I'll press play and.
Hello everyone. So sorry I couldn't join live,
Yes,
but
we
Arthur
can
asked
see
me
it.
to make a quick presentation for you. My name's Aaron Porterfield. I'm a product designer who uses Rhino and Grasshopper, and I wanted to tell you a bit about my story and the kind of work I do. So most of my work is kind of revolved around researching new materials and processes for product design.
It's a very new, so let me try and see if I can.
Design. And I started using Rhino and Grasshopper to kind of leverage the connection.
You're not hearing the voice of Aaron when I'm playing?
That's correct.
I'm hearing it.
I'm hearing it.
Okay.
Oh,
good.
everyone's hearing it? Okay, good. Okay, cool. Thank you for letting. I can't actually see any of you, so okay, I'll continue pressing play.
Between parametric design and digital fabrication. So this means 3D printing, laser cutting, or any other kind of technology that we can utilize to design more innovative products. I'm also in love with the open source community, which is really how I learned everything I know today. So my contribution back to the Grasshopper and open source community is Crystalon. And Crystalon is an open source plugin for generating lattice structures in Grasshopper. And if you're interested in learning more, you can find it on foodforrhino.com. But where it all began is when I started publishing my own personal projects on a platform called instructables.com. This is a platform for makers to share their instructions on how to make things. And the most interesting project I published was about lattice hinges. This is a process using a laser cutter to create a pattern of relief cuts into a material so it can bend into 3D shapes. And this project actually got a lot of attention. I found thousands of people all over the world who have found my instructions and were trying to make it themselves. And this is actually how I met Arthur. We met online, not on Tinder, but on Instagram actually. And he found my open source instructions and used the technique for an installation. And since then, Arthur and I became friends, and he invited me to build projects with him at the Burning Man Festival in the US. The latest project with Arthur was the Galaxia Temple in 2018. My role was the US lead, so while Arthur was in London, it was my job to kind of manage all the operations in the US. This meant help organize the build team and help manage all the logistics of materials and fabrication. And this was by far the biggest and most intense project I've ever worked on. The design was made completely in Grasshopper, as well as most of the engineering, but also all of our fabrication drawings and logistical planning. We also had to break a lot of standards with this project because we had a team of 150 volunteers with very little construction experience. So our design and our construction drawings needed to maintain a certain level of simplicity. So I think what made this project, which most people called impossible at first, really become a reality is the ease of our collaboration between design and engineering and fabrication across multiple countries and across different skill sets. And I think that's also what makes the Rhino and Grasshopper community really thrive, is this circular loop of feedback and development throughout an entire community across the world. So I hope you like Rhino 7, and thank you.
All right, I hope everyone managed to hear. I think you might need to maximize your screen. What I'm going to do is to play a video from James, the engineer that I've worked with during a long time. So he's going to be the second surprise collaborator to speak. Let us know if you have any problem in the chat. I think people were asking.
And
yeah.
I think that's recording. So yeah, hi everyone. Thanks for letting me speak today, and thanks for Arthur for inviting me. I'm James Solly. I'm a director at Format Engineers, and I was asked to say something briefly about Rhino collaboration and working with Arthur. And I think a big part of my job on projects we've worked together has been summed up really nicely by this small video clip.
James, if you remove this one, nothing's going to collapse.
Arthur giggling in the background. And I want to start saying, I feel like when I started engineering a bunch of years ago now, this was very much the approach. We had the architect, then the engineer, then the builder, and this was something where information flowed downstream, and this was how things were done. I think this is the utopia. This is what Arthur is always pushing us for. I'm not sure we're there yet. Every project is an experiment, and I think we're probably right now more in this sort of space where we're passing data between us, and for us very much that's relevant to you guys in this Rhino user group. But I wanted to mention that I've talked a few times where I've talked about how new computers are for engineering, that actually everything we do, simulation, everything is from like the 1960s. And so it's actually super new. Like computers in building structures in the grand scheme of our world is really new. And the first structures that seem to really use computers in the creation of them in any way are still standing. You know, they're still within their building lifespan. So it's still a really exciting time. Like everything we do is a progression that's happening at an insanely fast pace. So for us, there are two key things that we love using computers for. And one of them is the creative part, you know, using computers and algorithms to help us do design, to help us uncover material directions, to help us make simpler fabrications, to simulate buildings before we build them, get more confidence before we start running with it. And a lot of those tools are happily hosted within a lovely common Rhino environment, which I'll mention. But the other thing, apart from those really fun and exciting, the stuff that's the core of our business in many ways, is building data and BIM as an entire concept, which we love, with this really bad sketch of being this big pile of data that floats between us and the architect and the designer and maker. And so that's probably the most important thing I want to mention, which is this pile of data that we pass around. And that data actually consists of several things, and probably one of the most important, I think, gets forgotten about when we look at the models and just BIM models is the construction thought and sketching, which can be like sketches that we use to determine like key structural details before we move into computers, but can also be sketching that we've done a lot of in this lockdown, like collaborative online sketching, where we've really like sat together digitally and worked out ideas before moving into that kind of fully computational space. But I love that technology now enables this. I mean, we're working with Arthur all the time on Slack and Google Jamboard, and that big pile of discussion becomes part of that project data at the end. And then the tools that we use that lead on from that are the ones that you're here listening to Arthur talk about, I think, which is Rhino, Grasshopper, bits of coding, Karamba for us, the structural analysis package. And that for us are the tools that we're using to interact with that data. So really briefly, I wanted to talk about the way we've worked with Arthur through the Rhino environment a lot, which has been through the use of breaking complicated projects down into geometric primitives. And this data really being, when we move into the main part of the project, very, very simple Rhino geometry, like points, lines, polygons, meshes, and Grasshopper scripts that Arthur and his crew put together, and tend to be really elegant mathematical solutions which produce things like this. And so in the designer and maker that is the architecture team, they have this very like elegant 3D mathematically generated piece. But for us, and the core data in this project was really lines that link to tangents in mathematics, lines that link to physical pieces of wood, and lines for us as engineers that are beam elements in a structural model. And because we hosted that whole project just around lines, there's a really lightweight Rhino file that can be passed around between the team, updated, changed, and changes can be handled really quickly. The same was very much true of Galaxia. I mean, a huge project, but at its core again was line geometry, lines building triangles. And from an engineering point of view, really a line is a topology that links 2 points. So we're actually at kind of core Rhino coordinates, just generating up and up and up from that like little granular piece of data towards something that ends up a massive 60-meter structure. And we're always, when working with Arthur, particularly of architects that we're working with, working on that granular piece of information. And every project we try and find the best, smallest piece of data that we can pass between us. So the file is actually bouncing between a hyper lightweight that then produce, for example, this project was meshes. These are very, very light meshes, and that was the file that sat in the center of this group. And Arthur had his scripts for generating this geometry. We had our scripts for structurally testing this geometry, and Arthur's team again had their scripts for then printing this geometry. But the central file that we actually interacted with was just meshes in layers. And I think that led to, that was our BIM, you know, and so it wasn't a crazy Revit model with every bolt modeled. Our BIM was this one file that we all knew how to translate into our own little areas of the project. So that led to, again, very complicated outcome from very humble geometry. And the same, we're investigating more and more these like different materials and how to print lattices. And I love that, again, this became a volumetric print. You know, there were huge amounts of data on volume objects, yet in our terminology, that again, they're lines and numbers. Every line has a thickness. When that becomes like Boolean altogether, you end up with a volume, and that's that. But when we're talking to each other and passing data, we're able to talk in the terminology of lines, data, simple mathematics that are hosted within Rhino and Grasshopper that generate these final, highly complicated outcomes. And that was actually all I really wanted to say. Thank you. Find us here.
Hello. We're back. I hope you can still see my screen. And I'm sorry for those of you who couldn't hear. Please let me know. Again, I can't see any of you, so hope you can see my screen now. All okay?
Yeah.
Okay, fantastic. Okay, so I have about 15 minutes to tell you a little bit about what these guys were talking about. Starting from, you know, very beginning, again, it's been about 10 years that I started working on projects with Grasshopper and Rhino. There is this beautiful thing that, you know, we're working with systems, not form. So what I mean by that is that once you start setting up parametric systems, you don't have a final thing. Things keep on evolving, and they keep on taking a new shape. They adapt to fabrication, they adapt to the site, to the materials that you deal with. And because you start sharing files, you end up being on site with people. That's one thing that I find really, really beautiful. And I think these guys talked about it, is how we all ended up, you know, doing things that I think we weren't doing when we were working in practices earlier on, before the sort of parametric, should I call revolution, which is, you know, we end up being in front of a model, touching it, making it, iterating, creating variations on the one-to-one scale. And so that's something that's been very present. This is the wooden wave at Burr Happel, in which we ended up being contractors, in which we iterated, you know, many times, and even the client himself became part of the design process, which is something that I thought was really interesting. Not only is the architect, the engineer, the maker in the same room trying to change things, but the client himself was advising. We had the flexibility to take risk, and I'll mention that during the Burning Man slides. The idea of being able to play with things that are usually heavily regulated is something that I thought was really wonderful. The other beautiful aspect, I think, of starting to work in this way is to start going from project to product. And I think we were all surprised, I don't know if all of you guys as well, by the fact that we all sort of had to go into coding. You know, I'm not a coder by training, but the sheer act of being empowered to look at what is code, or what is the logic behind code, has led to new projects, new things that I really thought an architect didn't have to handle. So this is Silkworm, which allowed us to send polylines and transform them into G-code. And talking about this, beyond the financial values, we put Silkworm open source with Adam Holloway, and these guys from WASP, a wonderful Italian company that deals with giant 3D printers, reached out, said we use Silkworm, sent us a giant printer, and we ended up printing these giant teardrop for the Galaxia project, which was a really wonderful proof that when you give, other people give. And so this has really redefined the way we work. Another beautiful aspect, and you know, I'm obviously very enthusiastic about it, is the discovery of sustainable material. 3D printing usually uses PLA. PLA, polylactic acid, because it has a low melting temperature, ended up being the material of choice, but it also happens to be made from renewables. And so it happens to be cradle to cradle. And so somehow the maker's revolution was now joined with the circular economy. And that's the spirit of this project that James was talking about. This is called Conifera. This is the creative director of COS, Karen Gustafsson, who actually, you know, asked us, you know, to collaborate with her. And we immediately tried to tackle the idea of fast fashion and, you know, non-renewables being used. And so this project had about 500 of those modules that were exactly the size of our printer. They were made of like a 3 millimeters cross section. It was about 4.2 tons. And all of these members working with James and his team were maximized in tension. So we tried to minimize the amount of compression and maximize tension using Karamba. And this allowed us to iterate and adapt these modules over time. You can see the output of Karamba here with the red lines showing breakage moments. And then you can see on the right our studios and the different fab labs that were working on this project at the same time as us, which I think is something that was really nice, is that we managed to print all this locally. Together with a community of WASP hubs, of places that had this giant printer, which allowed us to reduce any transportation cost. And in that spirit, the project on the right, the Sand Waves, came in a similar fashion. We wanted to have a project that we print with the local materials, and in this case, sand. And so when we started, this is with Chris Presch, the wonderful architect from Austria. We thought, well, we're going to print this giant version, sort of the COS module, and make it inhabitable and try to build it with sand. Obviously, a little bit naive at the beginning, thinking that we could print such thin cross sections. And we quickly realized that we'd have to, you know, go bigger. And that came from discovering that sand printer. This is an X1 printer. It requires specific kind of information. It's very different from FDM printing. And so we ended up putting what's called an octet truss, which is a truss developed by Alexander Graham Bell using intralattice, and then placing it in Karamba and getting these cross sections. We had to break quite a few. And we had some of these modules. They were printed in a yin and yang fashion so that they would fit inside the print bed. And then all of these were assembled into these dancing structures. Okay, so I've got about 8 minutes. I want to bring you to the more educational aspect of, I guess everything is a little bit educational, but we wanted to involve, with my colleague Toby Burgess, we wanted to involve people because we thought it would be a better way to teach, is to involve and build. And we ended up finding this amazing playground called Burning Man. These are the 10 principles. This is the founder who said, I elevated passions into duties. And that's not enough. And so something that people might not know about Burning Man is that there is a ticket that says you might die at the event. And I know it's tricky, but I think we are so de-risked as an industry that it's sometimes hard to you know, innovate, because everything is separated from you. You end up being in a desk doing things that are not necessarily related with the risk that a contractor might take on site. And instead of doing art about the state of society, we do art that creates society around it. I think that's a really core statement of Burning Man, very much in line with the idea of being in charge of operating a spaceship Earth that Buckminster Fuller was advocating. So with our students, we've built, you know, at Burr Happold, they are obviously used to using very cheap systems. You know, they're students, so they're obviously financially strained. And so we always told them this was a luck. If you manage to build things with reduced means, or in this case during COVID, without having access to big machinery and stuff, this is maybe a luck, because that means you'll be constrained to think economically and with logistical ideas. And I think this is what happened to us. You know, this is the story, for example, on the left of a very complex, I don't know if Daniel Piker is online, but this is using one of his rheotomic surface with complex numbers. And on the right is the bismuth bivouac, which is a much more kind of a simple way of adjusting 2x4 side by side. And these are really what happened to us. The infinity tree on the left ended up being a puzzle that didn't have any naming system, and we had to like classify everything. And because nothing was really named or nested, and it's our fault, but it's a big learning curve, because when I saw this is the truck. You had on the right side the bismuth bivouac, which are the 2x4s, standard off the shelf timber, and on the left, you know, the project that was a big reciprocal structure. I quickly realized that, you know, I need to kind of rethink maybe digital fabrication with a more standardized or off-the-shelf approach. And I think this was the biggest learning curve on Tangential Dreams. We wanted to use 4x4s, 2x4s, 1x8s. We wanted to look at the industry, the brackets, the circular saws, and develop systems based on what we can find in the market, if I say so, or in the most common knowledge of carpentry, to mix, you know, in that James talks about humble geometry. I think that's what we wanted to do, to be humble in face of the carpenter, to learn from them, to learn what they've been doing for forever, not think that Grasshopper would somehow revolutionize things that were done for a long time. And so Tangential Dream was a bit of a turning point, at least in my mind, of a geeky Grasshopper, right? And so the other really beautiful thing that I've discovered at that time was the temple. The temple is a spiritual space, and this is a giant CNC, probably one of the biggest CNC plywood structure. And this was, you know, it was in 2013, and I realized this would be a really interesting place to also bring that spiritual nature to what ends up being otherwise very algorithmic and potentially probably dry at to some extent. At the same time, I was working on this project. This is using Hoop Snake. We were growing these vectors in space, and this was for Virgin Galactic. And I guess going to Burning Man and seeing that project and developing these ideas of the inverted dome, it made me rethink a little bit what a spiritual space could be. Given that sort of bottom-up approach. If you're bottom-up, it means that you're coming from the people, from the material. And yes, there is something relatively humble to that. And I think people can relate maybe a little bit better because it comes from them. It comes from their scale, and then it's elevated. In this case, you know, it starts at human scale, elevates into a central space, and is a fully lattice-like structure. James was talking about lines and points, how they're very essential, primal in a way. They're very, they relate to us. Our bones are made of that. And so in this case, we had this really empty lattice that people filled up with joy, with sadness, which is really the universal concept that everyone can relate to. And so that project was that project was a really wonderful challenge. Obviously, we had only 18 days to build it, 140 people on site. Everything learned from projects that I showed you, the rotationally symmetrical, using components that were off the shelf. You can see the elements here, the screws, the 4x4s, and what James was talking about rethinking the newtons. For example, I like that slide because it shows us a different way of thinking engineering. Engineers were sending us the formulas and the forces from Caramba, and we received the compressive value and the tensile values, and they gave us an equation for each screw. And so every one of these brackets were thought in relation to the forces going through the structure. So we could tell people, well, if you see one of those that are longer than others, it means that more kilonewtons are going through them. And this was really interesting, this honesty about the construction process, about the funding, about the cost, about everything had to be a discussion, a constant discussion. And in that sense, we had to communicate how we're going to build this. You have to think that this was 140 people that weren't necessarily skilled with carpentry. And so we had to think of the assembly process, the truck that comes in, the way we're going to lift this. I learned about cranes. I learned about, how many cooks there should be and who's going to cook when. And so it went way beyond the, let's say, the architectural, and it became the, the human, the journey, the collective sharing of a structure and how to communicate to people, and so how to relate to the general public to some extent. And so we opened it, and people continued to build, and we had these really moving elements that started kind of populating this incredible structure. And I thought, with my wife Sandy, that it would be a good moment to celebrate our marriage. And so we ended up, getting married in the structure. And this was, I guess, our ritual, our way to relate to the people using it. Another beautiful moment was when the Native Americans blessed the entire team, telling me that any structure that is sacred to them. And so that was a really special moment. It lived not for long, for a week, and then we burned it collectively, because that's the ritual of the temple. It's the idea that you fill it up with a lot of things that you want to let go of, and then you burn it in quiet. Then we cleaned it. We removed every single piece of steel from it, and we tried and manage this fire, which obviously, it's not great to burn projects. And so this is the next project we wanted to do at Burning Man, and I'll finish on that. This is Catharsis. It's an amphitheater made of amphitheater. It's based on also complex numbers. We're back to it. Maybe the loop is looped. The Poincaré disc. It's a modular structure that is meant to be disassembled and reassembled at the Somerset House, which hopefully will happen this summer. If not the summer after, we can be patient. That's the beauty of modular structure. And this is probably the final image. The general idea of the life cycle of materials that you probably saw from all the way from where it comes from, renewables, all the way to where it's consumed and the client. This is a tower we wanted to do in the Silicon Valley, which has a restaurant that serves the food that grows on the structure, all in timber, sort of giant version of Tangential Dream / Galaxia. And yeah, so I guess that's all I wanted to show you, guys. I look forward to learning about the tools of Rhino 7. But I mean, I cannot be more grateful to all of you and to the community of McNeil for having taught me all these lessons, and hope you guys can join us for our next project or anything. You can contact us. Thank you very much.
Much, Arthur. Fantastic. Now there's an opportunity for questions for Arthur before we move on to Phil's Rhino 7 presentation. Any questions for Arthur? I know some people are giving you a round of applause, a virtual round of applause, Arthur. So yes.
Thank you, guys. I saw a nice question, if I may. I think Phil has posted it on our WhatsApp. He says, "Do you think your process will lead to building something more conventional, like an office building, but with your new method?" That's a really, really good question. Well, I'm building my house at the moment, and it's been a very interesting process, because you're right. It's not, a house is a house. Like, it needs a bed, it needs and we speak with my wife all the time about how can we still bring this approach to our scale. Like, we're actually, paying for it, so it sort of hits home in a way more than some fundraising. We're actually spending money on it, and so it's been a really interesting. I hope I can show you this next year. We're working on several projects that are actually an office building, strangely enough, our home, and some stores. We're building worldwide stores for a brand. I cannot speak about all this, but that will be the next round of presentation. But yes, it's applicable. It's just a little bit more. I don't want to use the word painful, but it takes a lot more time, which is why I cannot show you those.
Okay. It's also possible that if any of the other organizers wanted to jump in, if they had any questions, of course they're welcome to join me here. But so I know that there's a question here. Which plugins do you use for structural form finding? Was one of the questions.
So this is mostly all the projects you've seen are done with Karamba. Karamba is I think Clemens Pressinger developed it. It's from Bollinger Groman, I think. It's a wonderful tool, and it's been really reliable. we couple it with Kangaroo, and I think there is even a Kangaroo 2 plugin for Kangaroo that deals with more precisely structural form finding. However, the coupling of Kangaroo for form finding, Caramba for sizing things and calculating deflection and bending moments, together with Grasshopper and our stuff, has been, perfect.
Thanks, Arthur. Okay, question from Andrew Phillips. Arthur talked about finance and risk. Engineers and perhaps lecturers are often risk averse. What's key in moving from the virtual design to the realization of the make?
It's a big question, and you're completely right. Risk is probably the biggest inhibitors to try something new, and it's hard to say anything else but to manage the freedom, in a way, the freedom to take risk can only happen if you find platforms where the client is enabling you that, or you fundraise your own project, which is another solution, and then you connect with people that are like-minded, which you think can take the risks with you. I think these three components were key to the freedom we had to do that.
Thanks, Arthur and Andrew. I know the answer to this one myself, but the question is, do you have a big WASP 3D printer yourself?
Yeah, I do, and we're about to get 3 more. They're called WASP 3MTs. They're wonderful because you can put all kinds of pellets in there, and I'm kind of surrounded with prints that we did with them. And this is the first time we can go architectural scale, really, which is really exciting. And we're actually finding solutions for fireproofing now, which is really, I think, the biggest revolution, to be honest.
Okay. Something. Okay, sorry. Right. Okay, from Ayan, a question. We need to learn computational design or conventional architecture, or midway between the two? And just something else as an aside to the same question. Do you like computational design or building your own cubist form house also? I don't know. Does that help?
I mean, it's a good question, because computational design, I guess, and I don't know if I can speak on behalf of computational designers, but when we teach Grasshopper, for example, I can see that it's a shift in the learning of a sort of more linear or continuous way of making, right? So when you sculpt, it's procedural, you have step by step. When it comes to parametric tools, suddenly it's almost like you need to be ahead in your steps, and you have to be aware of the entire system at once using lists and stuff. So suddenly it looks like you're playing chess and you're recording all the moves all at once. So it's a very specific way of thinking. And I think that's why, this word parametricism came about, because everyone realized that this thinking required something different. And it led to forms that looked like natural stuff, a natural form. It kind of did, like when you see the project that emerged from this generation. And so I think it's good, but like I was mentioning with the infinity tree, I think we can easily be drawn to the form finding and the shapes without realizing that when it comes to the realization phase, which is often something we're disconnected with, we don't know the material behavior. We don't know if, the traditional craft, like whether it's metal cutting and folding, whether it's timber, the carpenter's been doing it forever. And so being able to talk to these amazing craftsmen is so precious, and you will only design better computationally or not.
Thanks, Arthur. Well, Nick just has the simple question of where do you find the time?
So time management, I think, is the most important skill of all.
Holly, I think her name is Holly, I think. Yeah.
I mean, it's a great question. Well, one, I have a wonderful team. That's why I started the first slide with them, and they're incredible. And It's an amazing thing to be able to be in communion with your team in harmony, so that you really can say one sentence and they understand you. And that's a really special, and it's probably the hardest bit for any entrepreneur, I suppose, to find the right team. And I've been so lucky with Paul. Like, I think we understand each other really, really well, and we know that this is a long-term thing. And I think with everyone here, we know it's a long-term learning from each other. And so time stretches when you have a great team.
Very true. I think we'll take this as the last question here from Raoul, and then we'll move on to Phil. Big question though. What are some of your favorite sources of inspiration?
Oh, wow. Wow. It's a really great question, because I read a lot, and every day I have something new that comes to my. But I think overall the greatest source is just walking down the park and like seeing an amazing natural geometry, seeing how nature's done it for billions of years of evolution. I think it's hard to compete with billions of years of evolution. And so I would say that will be the greatest one, is just to walk, and actually it's quite healthy during COVID to do, to actually take a walk in the forest and have a look at how nature has done it.
Good answer. Great. Thanks, Arthur. So thank you for your presentation once again.
Thank you very much, guys. Thank you so much.
I think now we're going to have the, I think we're going to go straight into the Rhino 7 presentation. So for those that did have any problems with sound, hopefully they've all been fixed. I saw that some people had some problems and they were able to fix them by changing some settings. And so I think we'll carry on. Please feel free to type questions as you think of them. That's fine. You don't have to type them at the end. You can type them during. Some of them, if they're more simple, we may try and answer them actually within the chat, and others will bring the team that you saw at the beginning of the meeting back online, and we'll all have a conversation together. Okay, so I'm happy, Steph, for you to do your magic now and go on to the next part of the presentation.
Excellent. Okay, here we go.
The first example I'd like to take a look at is this table design. Now, this is modelled as a conventional NURBS polysurface, and one of the areas where we may have an advantage with sub-D is in creating variations of this transition between the underside of the table and the table leg. As a NURBS model, anything that changes either of these two trimmed edges at the end of the transition may involve quite a bit of work in managing the continuity of the surface between those edges. In sub-D, we don't have that problem of managing continuity, because the whole of this table is modelled as one continuous sub-D surface. That surface is roughly analogous to a degree 3 NURBS surface, in that it is curvature continuous, although we can of course add creases to edges to give this definition that we see here across the top of the table. If we look at the transition in the sub-D model, you can see that we have a fairly simple four-sided topology, but the shape of the transition is slightly more asymmetrical than that of the NURBS model. So let's have a look at how we might create that transition in sub-D. A simple way of creating this is just to start with one of the four quadrants that make up the table and with our known quantities. In other words, the underside of the table and the table legs. So I know what these are going to look like, and what I need to investigate is what the transition is going to look like. I'm going to use a tool here which is roughly analogous to blend surface in our NURBS tools. And I'm going to remove a sub-D face and create a blend between the two open edges. Now, it may be helpful to use the boxy mode here, which I can enable using the tab key, and I should point out that you need to have the same number of edges on both of the two openings that we are blending between. The tool that I'm going to use here is called Bridge, and I'm going to use sub-object selection and double click
to reveal the whole of the loop of this edge, and then enter, and to pick the second edges, double click again and then enter to get into the preview of this tool. Here I can add segmentation into the blend to tighten it up, and I can also play with the straightness of the bridge or the blend here. Once the blend is complete, I have some nice tools that allow me to move edges, for example slide edge, which allows me to move, in this case, an edge upwards and downwards to play with the shape of the blend, or I can just use the same tool on just part of this edge and slide this edge along to give me, in this case, a slightly more eccentric blend. So that's the way in which we can create a blend which is roughly analogous to blend surface, where we're blending across a gap. Let's now have a look at what we can do where we have a hard edge. So this is an edge on the sub D here where I've created a crease, and we've got effectively a cap on the bottom of that edge, and in NURBS, I guess here, the tool we'd be using is fillet edge, and in sub D we have a tool called bevel. So I'll pick bevel from the sub D tools, and again I'll select this edge and zoom out a little bit here so we can see what's going on, and enter, and you'll see that I can give this a number of segments, and I can push and pull this blend and play with the shape of the bevel. So this is a really nice quick tool for taking, for example, a hard edge and softening that slightly. Now that we have one quadrant complete, I'm going to switch to boxing mode, and then I'm going to go to transform and mirror this about the y-axis, and then I'm going to repeat that mirror tool and mirror about the x-axis. Next I'm going to take all of these four parts and join them together, and I want to make sure here that I choose the smooth option. And now, finally, all that remains for me to do is to close up the hole in the underside of the table. So I'll just select all of that edge and go to my sub D tools and select the fill hole command. And I'll use a single face to close that up, and the result is a single closed sub D surface. Next, I'd like to look at the idea that sub-D surfaces aren't just about approximation, and indeed we can create controlled sub-D surfaces from some defined curves by using surface commands just like we can in NURBS. The shape that I have on screen originates from our Simply Rhino Level 2 class, and here this is defined as a single NURBS surface, and this is created from a number of curves that all have the same number of control points and whose control points are aligned along an axis. And in that way we can create a surface that has a regular rectangular topology. Now, although this surface is built correctly, a consequence of the way that it's built is that we have a singularity on each end of the surface. And of course, if we modelled this as a sub-D, then we could avoid that singularity by virtue of the fact that we can close this surface off with a single sub-D face. Now, one of the things that's interesting is that just like NURBS, sub-D surfaces describe a different shape when they are open to that when they are closed. Now, if I was to select the faces on each end of this form and remove them, then you'll see that whilst the centre of the shape stays the same, the way in which the ends are defined differs quite a lot. Now, the relationship between the open and the closed sub-D is fairly easy to predict, and to this end what I can do here is to start by laying out some curves with which I can define an open surface. I can then close that surface to give us the result that I want. Here, for example, what I can do is go to my sub-D menu and use Sweep to Rails, and I can pick these two closed curves as the rails, and then I can pick the 4 open curves as the cross sections. I'll see a preview here very similar to the NURBS preview, where we can match the number of segments to those of the curves, so that we can get, if you like, an explicit number of segments into the surface. Then I can take the end and I can go to my sub-D tools and I can close off the end with a single face at each end. Now all I need to do is to pick these ends and go back to a reference and adjust the shape slightly just by pulling out the faces. So you can see that we have a fairly controllable way of creating a sub-D alternative to my original NURBS form. Another couple of useful things here are that, first of all, this shape is symmetrical about the y-axis. So I can pick the sub-D and I can apply a reflection. I can choose the y-axis and I can pick a point on the side of the object that I want to keep, and now you'll see that half of my object is a darker grey. That's the reflected side, and what this now means is that if I, for example, pick an edge here and pull this edge to change the shape, then I'm going to have a symmetry on the reflected side. Another significant change since we created our first sub-D video when Rhino 7 was in work in progress is the way in which the NURBS conversion is handled. So if I pick this object now and I use the Convert to NURBS button here, you'll see that I have some sub-D options. And not only can I control how the extraordinary vertices are handled, but I can choose to have either unpacked or packed NURBS surfaces. When I choose packed, I'll have less NURBS surfaces making up the polysurface than I would do with the unpacked option. If I turn off the isocurve display here, then you'll see that now, rather than having 8 NURBS patches in this middle section, it's now built from one single surface. And this is much friendlier for downstream editing in NURBS. The next new sub-D tool I'd like to take a quick look at is called Multipipe. This is a great tool when you have either a number of lines or a number of curves that share coincident endpoints, and you can quickly pipe these and create these smooth transitions at the pipe junctions. So let's just take a look at how this works. So I'll turn off my existing example and I'll just pull back a little bit on the view here, and let's select these lines, and then I'll go to my sub-D tools and pick Multipipe. I'll define a radius, choose whether the ends of the pipe are capped or not, and I'll choose a number of strut divisions. Now these struts are the segments between the endpoints of the curves. So for example here you can see that there are 2 segments, and if I undo the command and run it again, and this time I include more struts or segments, you'll see that we get a longer portion of straightness and a sharper corner. Again, if I redo this and set this to 0, then I'll have really smooth transitions. Once you've created the multipipe, then of course it's fairly easy to add and remove segmentation and play with these shapes and maybe remove some edges to get a better topology. Here, for example, you can see that I've added a little bit of sharpening to the inside of the frame and to the inside of this chainstay. One of the areas where there's been a significant improvement in Rhino for Mac is that of page layouts. If we go back to Rhino 6, you'll remember that to go from model space to layout space, we needed to change windows completely. and these windows didn't share the same tool palette. So this was very different from Rhino for Windows, for example. Now in Rhino 7 we have a completely integrated layout. So we have these tabs at the top where we can go from model space and our various 4 views here, and we can go into layout space and we've got our normal panels here. So we can see the layout in detail layer information up here, and we've got a new layout panel here. This layout panel is also in the Windows version, and this lists all of the layouts, and we can just double click on these and work through them. So this is now a really nice simple interface in Rhino for Mac and an improvement in Rhino for Windows. Now let's look at some more new features in version 7, but this time we'll do this inside Windows. I'll start by taking a look at a command called QuadRemesh, and this command sits in both the mesh tools and also the sub-D tools, and it has a fairly close relationship with sub-D, as we'll see shortly. Here I have a single NURB surface which has a little bit of curvature detailing here and a sharp crease here. And ordinarily, if I mesh this using the standard mesh tool in Rhino, I'm going to end up with a fairly dense mesh like this. And that mesh is a mixture of quad meshes and tri-meshes. QuadRemesh, however, gives us a new way of meshing. I'm going to run the tool and pick the surface that I want to mesh. And I can then calculate the result either based on the target edge length or the number of quads that I want to use. So I'll start with target edge length and I'll preview and hide the input object so we can better see the QuadRemesh result. Now you see we have a number of settings here, and I'll first turn on detect hard edges, and this will keep the crease in here. When we use target edge length, all our quads are going to be pretty much the same size, whereas if we switch to target quad count, there is an amount of adaptation in this, which lets us have smaller quads where there is more curvature or detail in the surface, and I can increase the amount of adaptation by using the percentage slider here. And now you'll see that I have bigger faces here where I have less detail, and smaller faces here where I have more detail. I'll set that back to 50 and I'll turn on adaptive quad count. What this setting will do is to throw more quads at the areas of more detail, and this will usually give us a higher quad count than we specify. As well as creating a mesh, I can create a sub-D. Now this sub-D is of course smooth by nature, but I can make this crease aware, and I can create corner conditions on the sub-D, and I can also choose to interpolate the sub-D rather than by creating it by its vertex points. And this will make the QuadRemesh sub-D fit closer to our target surface. One of the things I can do is to change the topology locally by using some curves. So I'm going to turn on these curves here, and I'm going to pick select curves in the dialog and choose these 3 curves and enter. Then I'm going to change the curve influence to edge ring, and I'm also going to invoke a symmetry along the x-axis here. And you'll see that now my topology is equalized about the x-axis, and we've created an area of topology with this circular detail to it. So I'll accept that result, and I'll just push that sub-D onto another layer here. So what I want to do now is to turn on the gumball and pick this middle circular edge and just pull this upwards a little bit. Now if we look at this with a reflective view mode, you'll see how this topology change allows for an easy shape change. One of the areas where QuadRemesh can be very useful is in reverse engineering. Here we have a fairly typical laser scan, and this one is from a Polyga scanner, and this is producing a mesh with 4.5 million faces. This is quite a dense mesh and certainly not something we'd want to work with directly. So let's have a look at trying to make some sense of this with QuadRemesh. I'm going to start with the settings at somewhere close to default. So a quad count of 2000, adaptive size of 50%, and adaptive quad count turned on. I'll also convert to a sub-D by interpolation, keeping sub-D creases on. I'll preview the result of this, and now you can see that the result is pretty good without too much effort. The topology of the mesh works out and traces the shape very well, and indeed the mesh is created based on principal curvature, so you can be confident that much of the time the topology is going to be empathetic with the shape. There's a bit of a problematic area here, but it's certainly much better than we had to start with, so I'll accept the result. You can see that we have some holes where the original scan data was open, but this is now something that's going to be much easier to fix going forward. And we can probably keep this as a sub-D and simplify some of the areas before converting to a NURBS polysurface and redoing some of the circular hole and threaded features. Another area where QuadRemesh could be very useful is in retopologizing terrain. Here we have quite a dense terrain mesh which is rather unwieldy, and we can produce a nice smooth QuadRemesh result and perhaps turn this into a sub-D so that, for example, we could do some local landscaping. Version 7 features significant improvements to rendering. Just as with version 6, Rhino features a rendered viewport which could be considered a sort of a preview of the ray-traced viewport. This ray-traced or cycles mode allows for proper calculations of reflections, transparency, refractions, translucency, etc. This ray-trace viewport, whilst being a live mode, does take some time to generate, and here, because of time limitations, I've reduced the number of render passes from 1000 to 500 and speeded up the video. If I go to the Rhino options and select cycles, you'll see that I can accelerate the ray trace mode either via CPU or GPU. And on the machine that I'm using here, my Quadro P3000 card is selected, as it gives better performance than the CPU. But you can also see that now in version 7 we have a setting called Optics, and this should let us take advantage of NVIDIA's RTX GPU technology. Essentially, these are graphics cards that are purpose-built for accelerating ray tracing. And we hope to be looking at these in the new year with the help of PNY Europe. But for now, we're using NVIDIA CUDA acceleration. The next change in version 7 is that now when you select the render button from Rhino, it's the Cycles ray trace render that is being used. Now that may seem fairly obvious, but in version 6, pressing render gave us the older legacy renderer. The render tab, here on the right, is where you set your variables for the render. So, for example, the output size, the quality settings, ground plane and environmental settings. So I'll hit the render button and we'll see the render process start and the frame buffer window appear. And this will also confirm that I'm using my Quadro card for acceleration. It's worth noting that rendering this way should be more efficient than rendering in the ray traced viewport. Now with any path tracing or ray tracing, whether it's cycles, V-Ray or keyshot, the results tend to be noisy, and it takes a certain number of passes, and therefore time, before this noise starts to dissipate. Now if you're familiar with V-Ray or keyshot, you'll know that these now feature denoiser components that can help to clean up this noise, meaning that we can get viable results with less render passes. The good news is that there are now denoiser components available for cycles in Rhino, and also that these work really well. These are not installed by default, and to do this I'm going to show you another new feature in Rhino 7, and that's called the Package Manager. From my New in Rhino 7 tab, I'll select Package Manager. Once this is launched, I'll search for denoiser, And you'll see I have two denoiser components that I can use on this particular machine. An Intel denoiser and an NVIDIA denoiser. The Intel denoiser will use CPU and the NVIDIA denoiser will use GPU. So I'll install both of these and restart Rhino, and it's also worth making sure that your NVIDIA graphics card driver is up to date in order to run the NVIDIA denoiser. I'm back now with my restarted Rhino, and if I check in Package Manager, I can verify that both components have been installed. Now I'm going to spin this view around so that I can get to a more shadowy area in the image where there will naturally be more noise in the render. And I'll increase the size of this window slightly. Now I'll go over to my render panel and choose Viewport Resolution and Good Quality, and leave the other settings at pretty much default, and I'll hit the render button. So we can see the render starting to progress now, going through the various passes, and I'll just leave it to render out a few more samples, and then we can look at the denoisers. The two denoiser components that I installed are here on this side panel, and the small checkbox here removes them from the list, and I can add them back in again here. These are all the post effects that I can add, and I'll add the Intel denoiser back in again. So let's start with the Intel denoiser. I'll apply that and you'll see how it smooths out the noise, and if I turn it off again, you'll see that the noise comes back. The NVIDIA denoiser is of course going to use the GPU, and we're already rendering with the GPU. This builds and behaves slightly differently than the Intel denoiser, but the overall effect is pretty much the same. So again, smoothing out that noise. If I just zoom in here and turn off the denoiser, then we'll see the noise more clearly. Now we could of course clean up this noise with lots of render passes, but of course that takes time, and so here the denoiser is effectively taking areas of similar tone and smart blurring those together to remove the noise. At the moment the render has only done a few passes, and you can see that perhaps too much detail is being lost, and we won't be able to resolve that detail until we've done a few more passes. But you get the general idea here that this is a really good way of being able to produce a viable ray trace render in much shorter order, i.e. with fewer render passes. The result is very similar to the denoiser that we see in V-Ray, for example. So in Windows we can use GPU for accelerating the render and for denoising. If you're using a Mac, however, then there is no GPU acceleration for rendering, and the only denoiser you can use is the Intel component. However, as you can see here, Cycles makes full use of all the available CPU cores on a Mac, and the Intel denoiser is very effective in reducing ray trace render times. Another new rendering feature in Rhino 7 is the inclusion of physically based materials. When I navigate to the Object Information tab here and select a material, you'll see that I have the new physically based option. Physically based, or PBR materials, are a compact format that allows a single material type to define materials that would usually need separate definitions. So for example, diffuse, glossy, specular dielectrics, metals, etc. Physically based materials can be considered as being platform agnostic and cross-platform, and you'll see that they are popping up now in many popular programs such as V-Ray and Unreal. When we choose a physically based material in Rhino, you'll see that we have a basic level of control by default, and we can also expand upon this by going to the detailed settings here. We can create these materials from scratch, but there's an increasing amount of materials available online, many of these being free, and an example of this would be cgbookcase.com. When we download a material, we'll often have a series of texture maps that are used to create the physically based material. Here I'm going to create a gravel texture that I downloaded from CG Bookcase. I'll start with a new physically based definition in Rhino and select Add Textures next to the detailed settings here. And then I can navigate to my textures. I can add all of these textures at once, and Rhino will give me an option of checking that the textures have been applied to the correct slot. And once I'm happy with that selection, that's all I need to do. Now this material has displacement applied to it, and you can see that this looks a little over the top, to say the least. This is because my planar surface is small and the displacement is set by default, in this case, to 100 millimeters. So I'm just going to quickly switch back to shaded mode, pick the surface here and change the height of the displacement to 3 millimeters. I'll zoom in and you can see now that this is starting to look much better. I'll change this again to 1 millimeter, and whilst we're waiting for this to build, I'll just mention that for displacement to work well, you'll need to create a dense render mesh, and so remember that you can set render mesh on a per object basis. Emissive materials are also new in version 7. These are part of the physically based description, but we'll also have a shortcut here. We'll really only see the full benefit of these materials when we're in ray trace mode. And also now, if I go to my environment and I turn the intensity down from 1 to 0, so that I'm excluding all environmental illumination, then we'll see the effect of these emissive materials. And you'll see that I can adjust the intensity of the emission here, and you'll see that the material provides illumination and lights other objects in the scene. I'd like to finish up by looking at a couple of modelling and analysis improvements in Rhino's version 7. Here we have a couple of surfaces that look to be fairly well matched when we look at them with the environment map. If I look at these with the zebra stripes, however, you can just see that it looks like there's a small discontinuity just here. Now, of course, the zebra stripes and the environment maps are mesh-based visual evaluation tools, but we have a new tool in version 7 that lets us analyse the continuity across a pair of edges in much more detail. This tool is in Analyze, Surface, and the command is called Edge Continuity. So here, for example, I can turn on the Edge Continuity tool, pick the pair of edges in question, and I can examine the continuity in terms of distance, tangency, and curvature. And I can set the values that I want to use here. So if I start with distance, then this looks okay. But if I switch to tangency, I'll start to see the problem here. And it's at this point where we are most out of tangent along this edge. And I can see the amount I'm out. And if I look underneath, I can see the graph here. And I can also, of course, set a value for these graph variables. Here you'll see that we progress from being tangent at both ends to the discontinuity at this point. I can also view the curvature continuity here, and it's close to tolerance here, but a little bit out. So I'll switch back to the tangency display and see if I can fix this problem by matching these edges. I'm going to go to my surface tools here and select Match, and I'll pick the rear surface as the surface to change and the front surface as the surface to match to. I'll match using curvature continuity, and I'll choose preserve tangency at the other end, and I'll use an automatic isocurve direction. So running that seems to have fixed the issue. Let's have a look at the curvature again, and now I can see that we've improved things. So this tool gives us really valuable feedback across pairs of edges, and we can leave the continuity markers on, and these will update whilst we make the necessary adjustments to the geometry. To finish up with, I'd like to take a look at named selections. Now, this command is often associated with the sub-D tools, and indeed it is very useful in this context. but it's also really useful when you are control point editing, for example. As you can see, here I'm selecting part of a row of control points in order that I can move them to bring out a surface feature here. Now, of course, if I wanted to select some of the points within that range, and not all of them, then I'd have to deselect and reselect, and this could be quite tiresome. So to remedy this, version 7 has a new panel called Name Selections. And I can save a selection of points, and then I can make any required changes to that selection, and I can save again. So here, for example, I have 3 saved selections, and this makes it really easy for me to pick the required points. Edit, pick another selection, edit again, etc. What's also really useful about name selections is that when I'm point editing, is that even if I don't have the control points turned on, then picking the named point selection will turn on the point display as part of the selection process. So, I guess I've got to the end of what I wanted to show today, and of course there are many other new and improved features, but hopefully this gives you a bit of an insight into version 7.
Okay. Thank you for that presentation, Phil. Okay, I think everyone will be joining us here, some of the McNeil people too. And then we'll begin with the questions. Please, everybody, I'd like to encourage you all, please type away your questions. We have a few to get through, but plenty more. Welcome. Okay. So we'll start with this one. Why not? Symmetry in sub D. Similar to functionality that we've seen in the past in T-splines. Are there plans for this, both along X and Y axis? But yeah. So could anyone take that question?
Yes, sure. So for right now, the only available symmetry with sub D is via the reflect command, as Phil showed, and it's only for one or the other axis, but polar symmetry and being able to do both plane symmetries is on the list. I'm not sure it's going to make it for Rhino 7, but it will come if not in the next version.
Actually, Dale, who is the chief scientist, is working right now on that. So I think that now his main topic is symmetry on sub-D.
Cool.
Okay. Another sub-D related question. And I know Daniel Piker's on this, so we could even put his mic on. I know I've probably just scared Daniel by saying that, but anyway, I'll ask this question and just see. Someone said, I saw the fuse command that Daniel had written for sub-D on the discourse forum. It looked very promising. Could we see this added in some way, you know, to, I guess, sub-D's own Rhino 7 toolset?
I think it would be great if Daniel could answer himself, because
Yes.
I myself has asked this to Daniel before.
Oh, really? Okay.
Yes, there's been talk.
I think it's also
I
on the works, but it would be great.
Well,
if
Daniel's offering to be unmuted, so maybe we do that.
Hey, everybody.
Hi, Daniel.
Hey.
Hi.
So yeah, the fuse command is there in Grasshopper now. So you'll see it under the Surface tab in Grasshopper, and yes, it's coming for Rhino 2.
Excellent.
Cool.
That's a great answer. Okay, thanks, Daniel. Well, let's see. Sorry, Phil, please feel free to jump in here because I'm having to sort of read the questions before I answer.
There was a question about, I'm just trying to find it, about retopology and about how
I think it was the very first question, Phil.
Phil's now
How
muted.
it compares to 3D Max? Was it that question?
Okay, I'll try and find it.
I think if Phil is talking, is mute.
Yes. Okay. Well, let's look at a different question. So this question for now: can you export regarding QuadRemesh? This is from William Chu. Hi, William. By the way, can you export the QuadRemesh into an ASCII file that can be modified so it can be read, for instance, by FEA software such as ANSYS and the like? Is anyone familiar with that area of things?
Which is the format? Just ASCII?
I think if you can extract the points and then save it maybe as a CSV file or a text file, that would work. I don't think the actual QuadRemesh, the mesh object can be exported, as far as I know. Yeah, but maybe Scott might know a little bit more about that. But yeah, you could extract the points without a problem and export that.
Okay. Okay. We couldn't hear you, Phil. So.
Right. Can you hear me now?
Yes.
Oh, right. Okay. I couldn't hear you either, Paul, for a moment. I don't know what happened. But yeah, the retopology question I was just looking at. I think one of the things to understand with retopology, particularly in the example of the scan that we looked at, is you are trying to simplify the data when you retopologize. You're trying to take something that's got, many thousands or millions of points and simplify that into something that is usable. And so there, in whatever you use, in order to get proper editable geometry, there is going to be some sort of difference, let's say, between the scan and the data that you end up with, because although the scan is accurate in certain points, very often there are inaccuracies also in the scan. So I think whether Scott or Carlos or Vanessa has more kind of detailed information on that, I think one of the important things to understand is that you are taking a very complex object which might be accurate at a certain number of points, but is very often the laser scan data is not useful for any real serious editing. You need to rebuild that and reconfigure that in some way, and that involves generally some sort of I wouldn't say approximation, but it involves some changes to the data. But from what we've seen, I think it's although I showed it as a fairly sort of push button process there, it's a very good start in the process of reverse engineering. But it's not, and I don't think there's any solution where there's a complete push button solution for this.
Exactly. Also, it doesn't fixes the mesh if the mesh is wrong or has holes or I don't know, duplicated faces or edges, etc. So it just recreates it with quad meshes and simplifies it if you want. Again,
it is a start of a reverse engineering process, but there is a long way to go. Andy, Paul, is there any way you can unmute Andy Le Bihan?
Yep,
he has something to add to this discussion about some of the commands that for retopology.
Great. Should happen momentarily.
Scott is back.
I am back. Do you need anything? Sorry, I've been back. I've been listening. So.
Oh, okay. Andy, are you there?
Hi, I am here, Paul. Can you hear me?
Yeah, loud and clear.
Great. Okay, I had an answer for the retopology question. I don't know the answer when it comes to how it compares to 3D Studio Max because we haven't looked at that workflow. But there are some tools available in Rhino 7 for doing retopology. The first of these is a new snap, which is persistent mesh snap. So you can turn on a persistent mesh snap for selecting points on a mesh. So if you've got a scan with like the one Phil showed with gazillions of vertices on, you can now snap to that mesh using any of the standard Rhino tools. The append command, or append face, I think it's called, is the tool for essentially drawing a mesh or a sub D onto another mesh. So using a combination of append face and the persistent mesh snap, you can basically build a retopology workflow onto a scanned object. And the final piece of the puzzle is that we now support pull to pulling of control points. So you can pull to a mesh, and you can so the idea is that you can pull to your scan, and that's what we have in Rhino 7 for retopology.
Yeah, the pull command is really is very powerful as well. For example, if you have used QuadRemesh to simplify a scan and then you want to modify that scan, pulling to another surface or another mesh is very powerful. We've been using that in training the last few days, and it's really good.
Okay, great, thanks, Andy. Right. Okay. There was a question, yes. Right, from Jack, who's on the call, but he emailed me this. Right, a quick on sub D. Are there plans to add sub D objects to the select tab options? Clear on what that is, Phil?
Do you mean on the selection toolbar?
Well,
I guess that's what he might mean. I didn't know that it wasn't there already, but it might not be.
I'm surprised it's not there because it's
okay. Well, if I haven't phrased that very well, we're happy for you to come and talk to us and explain the question. Otherwise, we'll go on to the next thing. It would help as well. Feel free to take some of these questions here, Phil, that are in the list.
Sure. Yeah. Okay, so one here, does Rhino version 7 have IFC file compatibility?
That might be one for Scott.
Yep, that one's for me. So, so the answer is for base Rhino, no. For the Visual Arc product plugin is your IFC reader, and the reason IFC is in Visual Arc is that IFC requires essentially, let's call it an expander. The IFC does not contain, the geometry does not. It contains the formula to create the walls and the roofs and things like that, but the actual geometry needs to be generated by something that understands what a wall and a window and an opening and all of those things are. So that whole IFC categorization is really important. And so the Visual Arc supplies that framework to Rhino so that it can understand both read and write IFC, true IFC models with real IFC objects. And so Visual Arc is your way to be able to support IFC in Rhino.
Okay, thank you, Scott. Another question here from Roman is, are there any improvements for working with highly detailed terrain survey meshes?
again, that's a realm of the plugin arena. The Lands design has been released, and Lands design has a number of terrain tools. In fact, it's got some really great ways of being able to snap to the terrain and place objects on the terrain and work with the terrain itself and do roads and all of those things. And then for the highly detailed, you're still working with for really large topos, you're still off in in Rhino terrain and that tool set, and being able to do the very, very, very large pieces. We have used sub-D and the QuadRemesher on really large terrains, and we are able to convert them to quads. We're able to use them with sub-Ds. You can run the place. Also, there's improvements to the mesh intersection tools. So doing splits and intersections with a terrain mesh is actually much better supported in Rhino 7. I don't attest that we have everything solved there, but it's a much stronger mesh intersection engine in 7 than it was in 6.
Great.
Okay, one more here, which I think has been, Vanessa has answered this in the chat panel, but it's I just thought I'd read this out because it's an interesting question, and the question is from Ramsey, and is there any way to make the corners of sub-D surfaces sharp instead of rounded as the default? And yes, and what you need to do is to essentially just pick the corner vertices or the corner vertex if there's only one, and just use add crease, and then you'll get the sharp corner. And in fact, you could see that in when we converted, when we were using QuadRemesh and built a sub-D. You can see that you can make it, you can make the sharp corners as part of that command as well. So yeah, that's all you can do. So although you think of creases as being things that you can add along a number of edges, you can actually add them to a corner vertex. Paul, any other ones that you've got there?
Let's see. We did. So I did miss a little bit there, Scott. But we had requests for. Is there anything in Rhino 7 that's addressed more working with larger point cloud sets? I mean, this came from an old point tools for Rhino user. So I think, Scott, you may know the sorts of features that they're looking for. This is more in a architectural context.
Yeah.
And I know in this company works with scans of heritage sort of older architecture.
Laser scans with shade and shadow and color. Yeah, I get it. Yeah. And the answer is, the display's faster in 7 in a lot of ways, and we can take more points. But it isn't a point tools replacement. We still don't have the ability to do those little GL glyphs and give it some solid feel to it. I'm not sure.
There is
go ahead, Carlos.
Arena 4D.
Okay.
Now I think they renamed the product. It's on foot for Rhino. It's, if I check it. It's now called Point Clouds for Rhino, and the company actually it's a British company, Besus.
So that's on food for Rhino. So that would be good to look at.
Or just Google Arena 4D for Rhino, and you will come to or Point Clouds for Rhino. It's a replacement of point tools that was acquired by Bentley.
Yes.
Okay, another one here, which I guess is probably a lot of people have thought of, but this one is from Bruce, is that can Rhino push sub-D geometry straight to Revit through Rhino Inside?
The answer is yes, sort of. I mean, you have to remember that. I mean, the answer is yes. If you take the newest Rhino Inside Revit from last week, and it will take sub-D geometry and make it a B-rep in Revit. Be careful, because it could take a long time. You get 1,500 sub-D patches, and Revit starts to kind of get a little antsy about how difficult that is.
So, yeah, Scott, forgive me for not knowing this, but Revit, I guess, doesn't have its own sub-D, does it? Is that correct?
No, it's an older, as far as I can tell, it's an older ASYS solids kernel. So it just has, it does have B-reps, and they are clean. It's a little picky about what it takes in, and so you get to these sub-Ds, and the thing it's important to understand about Rhino 7 sub-Ds is there always is a one-to-one correspondence between the sub-D and a NURBS B-rep. So the not every B-rep can be a sub-D, but every sub-D can be a B-rep. So when needed, Rhino 7 will push a B-rep down the stream, and therefore we can avoid the necessity to require Revit to have sub-Ds internally. But you can take that geometry over. It's a B-rep over there. It can be part of a family, for instance. And it will get sliced and diced and hatched just like any other B-rep. But I just warn you a little bit, you can get a really big sub-D in Rhino, and Revit will take a while to work with it. So.
Okay, thanks.
Okay, of course, we should probably say that we could have spent the whole presentation just featuring on Rhino Inside and Rhino Inside Revit over that whole time. Tonight was more about having having the perspective of something that suits, is interesting to all design disciplines. So we were kind of more focused on that than we were. Well, we didn't talk about Rhino Inside at all in Phil's presentation, and really, it's a big subject, and for another time. And yeah, so just wanted to mention, of course, that we didn't really go into that. Phil, I know that there was a question that you forwarded to me that was related to, you could probably describe it better than I could, about the meshed human figure that was taken from Rhino 5.
Oh yeah. This was a user that had a fairly standard mesh figure, like the ones that you can buy commercially, and I think they'd got it originally as a converted, or bought it into a Rhino 5 file, and it was slowing down the rendered view quite considerably. Is there advice for them on bringing quite sort of heavy meshed objects like that into a rendered scene, and getting them to not slow things down, or indeed is it better to use newer to save the mesh figure out as a newer Rhino file format before that comes back into a scene?
Yeah, so a couple things on this. I'll take this one. So first of all, we want to see that file. So if you have it, if you can share it, go on the forum, talk about that, and we'd love to walk through that and take a look at it. If the object is already a mesh, and so you have it's already just a very, very heavy mesh, you have very few things that you can do, right? There's not a lot of flexibility. And so what I'd recommend, if it is a mesh, if it's a NURBS already, then changing the mesh settings and maybe even changing the mesh settings just for that object could make a big difference, a really big difference. But if it's already a mesh, what I do is actually I'll use QuadRemesh, convert it to a sub D, and now I have flexibility to adjust the render mesh that's going to be delivered to the renderer. And so that's one of the advantages to kind of converting that dense mesh back up to a sub D and maybe even a NURBS. Then you have the ability to remesh, and whether it's lighter or heavier, depending on how close you are to the object, things like that. Where when it's already a mesh, you don't have that flexibility, and that's one of the advantages that QuadRemesh should bring you.
Okay, all right. We'll try and see if we can get the customer to give us a file for that.
Yeah.
And see if we can.
You can work with Andy on that and stuff. And
okay, cool.
Yeah.
Okay, great. You see the question there from Steve Bunn? When I export a model, okay. You see that one, Phil? 1955 from Steve Bunn.
Yeah. When I export a model for 7-axis machining, I use either STL IGES or Parasolid. How would I export a QuadRemesh?
Well, he could always use STL, obviously. If he wants to stick to exporting the mesh.
Yeah, STL will convert it to triangles, although they'll be within the quad boundaries, so they'll be fine. Yeah, DXF will take quads, FBX will take quads, OBJ takes quads.
Yeah, I guess that really depends on what his host is going to accept there. But yeah, all those formats that Scott mentioned there are accept quad meshes. STL is tri meshes. Okay. Just looking through.
Yeah. Rahul asks, is the forum the best place to make feature requests, or is there a better way for customers to communicate with McNeil?
I think the forum is the best place, although feature requests for Rhino 8, we haven't started that discussion yet. But of course, they can always, it's the way we do it. It's through the forum. Of course, if they have specific feature requests, they can always send an email to support@mcneil.com. But of course, in the forum, it's better because then you get a discussion ongoing, and then we see how much interest there is also. So for us, it's a good tool. I'd say. I don't know, Scott, what do you think?
I totally agree. The forum is the best place, and you get first of all, you're going to get directly to any developer that's involved with that feature, and so it's going to be the person that would write it, which is great. The other thing is, if there's other people that want it, everybody gets to gang up on us, and I think that's always a big advantage, as opposed to like sending it to support or something like that, where it's you're kind of just it looks like one voice until everybody starts piling on. So I think the forum's a good place to have the discussion, and it's open to everybody, and it is a very nice place to do this.
Okay, yeah, this is a question that comes up in different sort of ways quite often now. Sub D and Grasshopper, and sort of people are asking, for more components. But perhaps, is there any news on that, Scott?
Well, we have a few, and like I think we have a QuadRemesher now, and we can get things to sub D, but there'll be more as we move forward. Again, it would be a great place to find out what people are trying to do with sub Ds in terms of Grasshopper. you know, how they're being converted, you know, or you know, what you're starting with. Are you starting with a mesh, and are you doing QuadRemesh and then going to sub D, or are you starting with a 0 level cage from another product? And you know, it's all those kinds of things. Yeah, just jump on the forum and ask. We have been adding features to Grasshopper, and so you know, it's not out of the question to add more. I mean, we expect to be adding more sub D stuff as we move along and find out what people are trying to do with it.
Yeah, I noticed that Daniel put a link into the Multipipe component, so he'd answered that in the chat, so that was nice to see. Okay, someone asks, is David Rutten still around? Yeah, David Rutten's still around.
David's still around. He's still very busy.
Yeah. Can you see anything else there, Phil, that's we can
no,
pick out?
Not that I don't think we've covered or answered individually. A couple of people have asked similar questions that I think we've covered.
Well, there was one thing about yes, that I had on WhatsApp. Given that it looks as though Apple do not have plans to support OpenGL going forward, what does this mean for Rhino for Mac?
Oh boy, it means we have a lot of work ahead of us, a lot of work. Okay, so this is actually a good question. First of all, it's very important to understand that the new M1s that came out are not supported by Rhino. We're currently, and that's Rhino 6 or Rhino 7. Rhino 6 will never support the new M1 chips. Rhino 7, we're working on it as fast as we can to make sure they work on the M1. It also means we have to move to metal, which is really the kind of the core technical question I think that you're asking there, and we are working on that. We have no idea how long it's going to take, but as soon as we have something working, you know, we'll let it out for people to try. But what it does mean is it's going to take some time, and we really have no idea, to scramble to try to support that new shift in chip and graphic. The graphic shift that Apple's forcing us through. So we're working on it, but be very, you know, make sure to read the forum before you buy a new Apple. Currently, Apple continues to sell their Intel-based machines, and that is really where you want to be right now. So,
okay. Great. Well, I think that might be the end of the questions. Anything else, Phil, finally, that you think that
I can't see anything here, Paul, no.
Okay, so if Arthur can join us back for a second, just so we can all say thank you. But so brilliant. So thank you, everybody.
Thank you.
I just want to say thank you to all the McNeil people. Thank you very much to Arthur for joining us. We plan to do these meetings now once a month throughout the whole of next year. So in different formats. As you know, these meetings have different kind of flavors. They can have more of a leaning towards Grasshopper. Some of them are leaning towards VR and AR content. We know that the next meeting, very likely it's going to be Grimshaw's will be the main presenters. So that one will certainly have some Rhino Inside content. But we'll see, and we'll let everybody know way in advance as much as possible about our plans for these events into next year. Just also want to say thanks. We had a couple of sponsors for this, PNY, who are who have helped us out with some Quadro cards, and to the guys. Well, they're sponsoring all these meetings. These Beam, the guys that they're a plugin developer. They make a nice, elegant solution for moving data from Rhino to Revit and back the other way. You'll find links to them both on our website. Okay. I think that's it. Is there something I've forgotten, Phil?
I don't think so.
No. Okay. All right. Great. So thanks, everybody. Thanks very much for joining us. As I said, it's recorded, so you can see this again if you wish.
Bye, everyone.
Thanks everybody.
Thank you. Bye.
Thank you.
Bye.
Bye-bye.
Bye-bye.